In this video, we'll solve a very interesting problem based on belt friction. So say you have a belt, first of all you have a pulley, and over that pulley you have a belt, and the belt or the rope which goes over the pulley is massless, but there's friction acting between the belt and the pulley. Let us say that the tension on this side is T1 and the tension on this side is T2, and the belt or the rope, it subtends say a total angle beta at the center. So if we select a very small portion of the belt, so it will look something like this, and say that subtends a very small angle d theta at the center. If we assume that T1 is greater than T2 and motion just impends, then we can say that the tension on this side is T plus dt and the tension on this side is just T. If the whole angle is d theta, then half of it is d theta over 2. And if we want, we can resolve T and T plus dt into their components. So because motion impends and this belt tries to go to this side, a small frictional force of dF acts on the small portion of the rope. So that dF will be equal to mu times dN, dN being the small normal reaction that acts from here, so which implies that dF equals to mu times, and what is dN? dN is the sum of these two, the sine component of t plus dt plus the sine component of t. So that's, you'll notice that if this is d theta over 2, this is also d theta over 2. Therefore this component is t sine d theta over 2, but t sine d theta over 2 is just d theta over 2 plus t plus dt times d theta over 2. So this gives us dF equals to mu t d theta over 2 plus t d theta over 2 is just t d theta, and dt times d theta, the product of two infinitesimally small quantities, can be ignored. So we get dF equals to mu t d theta. Now because motion just impends, we can assume that the acceleration is 0. Motion is just beginning to happen. So the horizontal forces will cancel each other out. So we can say that t plus dt equals to t plus dF. If I cancel out the t's, I get dF equals to dt. So in place of dF here, I can substitute dt. So I get dt over t equals to mu d theta. And if I integrate both sides, in going from here to here, t changes from t2 to t1. And in going from here to here, beta changes from 0 to beta. So my final, not exactly my final answer, but we are almost there. Log of t1 over t2 is mu beta, which gives us t1 equals to t2 times e to the power of mu beta. Now this is a very interesting equation. What it says is, if I have a large mass hanging over here, say T1 is very large, I can make T2 very small just by controlling beta, by increasing beta. So we can do an experiment in which we can hang a very large mass on one side and hold that mass with very little force, with a very small force, just by wrapping the rope up many number of times and thereby increasing beta. This is an exponential function. So by controlling beta, we can make this term very high, and we can make T2 as small as we like, and still we'll be able to hold a very large mass. So let us end this video here.